In this next example, we're going to attempt to model what the population density on the unit sphere would look like. And so this is kind of an attempt at modeling the population density on Earth, but assuming sort of an average population density across the entire sphere rather than, populations being clustered. Okay, so here we go. We have a function, okay, when we want to find the total population. That is to say, we want to add up all the little densities and get the total. Okay, so using our knowledge, okay, so we have a scalar function, right? And being that we just studied scalar surface integrals, perhaps we need to use a scalar surface integral. So that means that we should probably find our surface and find a parameterization for the surface. Well, the surface is precisely a unit sphere, so that's sort of our x of d. All right, so then let's get this parameterization going. Well, we know that the sphere can be nicely parameterized in spherical coordinates, so let's use phi and rho, and we're only looking at the very surface, so phi and theta and phi, that's what those are. And so our surface has a length of 1, so it would be rho, and then sine phi cosine theta, but rho is just 1, and then we have sine phi sine theta, and then we would have rho cosine phi, or just cosine phi. Okay, and then we should of course include, okay, theta is within 0 to 2 pi, and phi is within 0 to pi. Great, lovely. Okay, so then let's go ahead and remember, per normal we would need to compute t theta and t phi, and we did that ad nauseum last time. So I'm just going to say, when we did the t theta cross t phi last time, we ended up just getting sine of phi. Okay, so I'm going to save us some calculation time and just say, there we go. Okay, so then the only thing that we need to do now is actually do the scalar surface integral. So the scalar surface integral over this parameterization of our surface, of g of ds. This is going to be precisely 0 to 2 pi, 0 to pi, and then into our function g we use our parameterization, so this is going to be 3000, and then 1 minus, and z is cosine phi, so cosine squared phi, and then we have the length of the normal vector, which we found was just sine of phi, and then this is going to be d phi d theta. Okay, and after you do some calculation, you end up with 8,000 pi. Okay, so in this world where we all live on a sphere, where this function g gives us the population density at a particular place on the unit sphere, well, we just say that the total population is 8,000 pi, or 24,000. That's interesting. But anyway, just a nice example of how to use a scalar surface integral.